Good morning, guys. This is just a quick video to show you a couple more examples so that it should make your homework in 1.5 a little bit easier. These were things that we were going to go over today. So I just wanted two things. One, just do another example of function notation, okay, giving a function and finding certain values, kind of like what we were leaving off with that draining a pool problem that we were working on last class. And then the other one is looking at a graph and just picking out intercepts. Both things that we'll do a little bit more of on Tuesday, but this will kind of help you get through your homework for the weekend. Okay, so if I have a function g of x equals 2/3 x plus 1, and I ask you to find g of 6, okay, so that would mean that I'm trying to find, so remember 6 in this case, right there is my input, and I'm really asking you for the output. Okay, so g of 6 is going to look like, I'm going to rewrite this function and I'm going to plug in my 6 for my x, which is my input, my independent variable in this case. And I'm going to do it out and let's see what we end up getting. So 2/3 of 6, so this can cross reduce. So we end up getting a 4 plus a 1, so we end up getting a 5. Okay, so it's kind of important the way we write our answer for this one. We don't want to say g of x equals 5 because that's not true. Okay, we only get a 5 as an output when we plugged in 6 as an input. So the proper way to write our answer would be to say g of 6 comes out to be 5. Okay, that would be function notation. And if I wanted to write it as an ordered pair, remember it would be my input is 6, my output is 5. Okay, so that would mean that if I were to graph this function eventually, 6, 5 would be an ordered pair on that graph. It would be a solution to that function, so it would be an ordered pair on the graph. Okay, so that one was I gave you an input, we found the output. So now it says I'm asking you to do find x so that g of x equals -1. Okay, so remember x is the input, so right here, this value that I'm giving you right there is my output. So that means it should go in for g of x, and you're going to end up solving here for x. Okay, so now I'm going to solve my equation. I'll subtract over my 1. So those are gone. I get a -2 equals 2/3 x. And then to get my x by itself, I'm going to multiply by the reciprocal. Okay, so that's gone. I just get x. And when I do that over there, the 2's cross cancel to a -1. So you end up getting out a -3. So that would mean in function notation, this would look like, sorry, it's not f, it's g. I would say that g of -3, because that was the input, would give me the output of -1. That's my function notation. And as an ordered pair, the ordered pair that would show up on the graph would be -3, -1. Okay. Okay, and then last one over here is I'm asking if is 12, 0 a point on this graph? Okay, meaning is it a solution to that function? So I'm giving you the input and the output. I'm really asking you, does it work? Okay, so let's see I'm going to plug in, I'm going to find g of 12 and see what happens. Okay, if it comes out to be a 0, then I know it is a solution. If not, then I know it's not. So let's find g of 12. So that would be 2/3 times 12 plus 1. So those are going to cross cancel to a 4. So I get an 8 plus a 1, so I get a 9. So that means that the ordered pair I just found was 12, 9, which means 12, 0 is not a solution. If I input 12, I get an output of 9. So we would say that no, this one right here is not a solution to that function. Okay, so you'll see a few like that on your homework. And then the last thing I wanted to do is just picking out intercepts on a graph. Okay, we started to do this when we were doing that draining a pool problem last time. But let's say I have this graph that maps the time and hours that you're driving and how far you are away from home. So let's first just kind of pick out the intercepts and then we'll describe them. Okay, so on a graph right here, okay, this right there is going to be my x-intercept. Okay, because that's the point where the graph is intercepting the x-axis. All right, so this is my x-axis, this is my y-axis. So that, in this case, that would be the ordered pair. Okay, 1, 2, 3, 4, 6, 0. Okay, and then this right here is my y-intercept. It's where the graph crosses the y-axis, and that would be the point 0, and that is a 70. Okay, so notice, for an x-intercept, your y-coordinate is always 0. For a y-intercept, your x-coordinate is always 0. So the meaning of these ones, for my x-intercept, this would mean that after 6 hours, I could word this a couple ways. The distance from home is 0. Or you could really just say at that point you're home. Okay, after 6 hours, the distance from home equals 0 miles. Okay. And the y-intercept would mean at the beginning, okay, after 0 hours, or just meaning your initial distance, okay, the distance from home, you are 70 miles from home. Okay, so that would be your starting distance from home, okay, before you start driving. Okay, just as kind of an extra practice, if we were looking at domain and range on this one, okay, so I have this connected, which shows that this is a continuous graph. Okay, means I can figure out how far away I am from home for any amount of time in between there. It doesn't have to be a whole number. Okay, if I wanted to figure out how far away I am after 1.57 hours, I can, or 2.12, whatever it is in there. It doesn't just have to be 0, 1, 2, 3, 4, 5, 6. But my domain on this one, because I'm going to be home after 6 hours, would be anything from 0 to 6. Remember, we're going to put our unit on it. And then my range on this one, okay, so I'm never going to be, in this scenario, I'm never going to be further than 70 miles from home. So my range would be 0 to 70. So I'm using interval notation because it's continuous. And that would be miles. Okay, so hopefully those two help you get through your 1.5 online homework. And then we'll go over, just if you've got any questions, just jot them down and we'll go over them on Tuesday when we're finishing up a couple other applications for 1.5.